Okay, so we thinking about this problem that we had to solve at the start, which was the integral of this. That's what we're after. Remember, we decided that the first thing was it's top heavy because the x cubed on the top there is bigger than the x squared underneath. So we had to use this method of polynomial division. It means it's a combination of whole numbers and fractions, the top of the fraction. We found out what the whole numbers are now. It's x minus 3. So we can integrate x, add 1 to the power, divide by the new power. We can integrate 3 becomes 3x. So this is now an easy part of the integral. All we're left with now is this bit, and that's partial fractions. So all we've got to do is use our method of partial fractions now on this to split this up into those two factors. So we've got to factorise this and then work out what the numbers a and b are to split it into those two factors. So we're going to focus now on this bit of it, the x minus 10 over x squared plus x minus 2. The first thing to do is to split this into its factors. What are the two numbers that multiply together to give minus 2 and add together to give 1? They were plus 2 and minus 1, weren't they? We were discussing this. If we multiply out those brackets, we'll get back to the denominator. So we split it. So that means this can be written as some number a over x plus 2 plus some number b over x minus 1. Familiar method. We now recombine the right-hand side and then work out the values of a and b by assigning numbers to x. So I'll pause while you do that, and then we'll move on from there. So this bit we have to solve using partial fractions. So the first thing to do is factorise it, as we said, and then split it. So this becomes a over x plus 2 plus b over x minus 1. Recombining, we get this over the denominator, so you can equate the numerators because the denominators are the same. And then if I let x equal minus 2, I find a is 4, and I let x equal 1, I find b equals minus 3. So this partial fraction can be rewritten as that. We can put that now into the original integral. So what we end up with is this. The original integral that we have to solve, remember, between the limits of 2 and 3, can now be split up using polynomial division, because the power of x is greater on the top than the bottom. I end up with a whole number, x minus 3, effectively. And then the remainder can be written as two partial fractions, 4 over x plus 2 minus 3 over x minus 1. And these now are trivial. We've done all the work because we can write down what the answer to this integral is now. So it equals, I'm going to use square brackets because I'm going to put the values in eventually. What's the integral of x? Add 1 to the power divided by the new power, x squared over 2. What's the integral of 3x? The integral of this is plus 4 log x plus 2. Minus 3 log x minus 1. And then I'm going to put my limits of 2 and 3. So all I have to do now is plug in 3 and then 2 and work out what the solutions are for each bit. So I use curly brackets and put the top limit in. So that would be 3 squared over 2. Minus 3 times 2, 3 times 3. Plus 4 log 3 plus 2 is 5. Plus 4 minus 3 log 3 minus 1 is 2. So that's the first limit, and then I subtract the same expression with the bottom limit. So we need a calculator to work out the natural log of these numbers in. So it will be 2 squared over 2 minus 3 times 2, 4 log 4 minus 3 log 2 take away 1 is 1. And that will come the answer. So I'll just pause while you plug the values in and see what we get. And we should end up with I think the solution is given at the start. So putting in the figures for the limits, we end up with an answer of minus 1.687 to 4 significant figures, and there's the solution. Now